Hello, welcome to my channel. In this video, I'll be discussing gravitational potential energy and gravitational potential. Before I go into the concept of gravitational potential energy, let me quickly remind you of what energy is. Energy is expended when work is done, okay? And work is given to be force times distance, okay? Meaning that if there is a body on a surface like this and a force acts on this body such that it move into another position, which is distance d from where it initially was. The work done here is given as the force times distance, okay? Meaning that anytime the force acts on the body and cause it to move, what is done? And what is expended in doing that work is the energy. Now let's go back to the concept of gravitational potential energy. You can recall from the Newton's law of universal gravitation. In my earlier video, I said the Newton's law states that every object in the universe attract each other with a force that is directly proportional to the product of their masses and is inversely proportional to the square of distance between them. And I also talk about the earth always trying to attract other bodies to itself. Let's imagine you are standing on the surface of the earth and holding an object, let's say a book up here. Okay. If you release that book will move towards the surface of the heart. The reason why the book moves is because there is a potential energy that is stored in this book that is due to the force of attraction by the earth on the book. And this potential energy that is stored in this book when it is released is converted to kinetic energy. Okay. The potential energy in a book that is due to the gravitational force that is acting on it is what is known as the gravitational potential energy, and it is given as mgh. And if you look at this could have probably sound similar to you because if you watch my earlier video on the Newton's law of universal gravitation, I said the weight, which is a kind of force, is equals to the mass times the acceleration due to gravity. And the height will be the distance. Okay, and recall that I said that work done is equals to force times distance. Therefore, the potential energy that is stored in a body that is held at height h from the surface of the earth is equals to the mgh, which is the potential energy that is due to the gravitation. Okay, so which is otherwise known as gravitational potential energy. Gravitational potential energy is the potential energy divided by the mass of the body. That is what gravitational potential is. Now, you should be able to calculate the potential energy of a body, let's say of mass 10 kilogram. Okay. If you are given a question in which a body that is held, let's say 100 meters at height 100 meter from the surface of the earth. If you are asked to calculate the potential energy, the gravitational potential energy of this body of 10 kg held at height h is equals to 100 meter from the surface of the earth, the gravitational potential energy for this body will be equals to mgh. And we know that m is what? 10 kilogram. Okay, and g is a constant which is given to be 9.8 meter per second squared. Okay, so times 9.8 times the height, which is 100 meters, and this is going to give you what? This is going to give you 9800 joule. Okay, recall that the unit of energy is joule. So that should be the gravitational potential energy of this mass. Now, one challenge with using this equation in calculating the gravitational potential energy is that the gravitational field, the force in the gravitational field is not uniform. And the reason is simple. If you watch my video on Newton's law of universal gravitation, I told you that as you move higher, as you go higher away from the earth, the acceleration due to gravity reduces. And the reason why it is like that is, recall from the formula, force is equals to the gravitational constant times mass of the earth times mass of the object divided by r squared. And this r squared is the distance between the body of mass m and the earth. Okay, so as this distance increases, so also the force decreases. And recall that in that same video, you can watch it, the link is shown in the top right corner below. You can click it and watch it. I said mg, which is the weight of the body, is equals to gravitational constant multiplied by the mass of the earth times the mass of the body all over r squared. And we say this mass cancel this mass, and therefore gravitation, acceleration due to gravity, is equals to gravitational constant times mass of the earth divided by r squared. So, and I said in that video that as this r increases, the g, acceleration due to gravity, decreases, and therefore the force, which is the weight of the body, that is the force exerted by the heart on the body, which is actually the weight, also decreases as the acceleration due to gravity decreases. You can watch my video on this for a better explanation. So, when the body is 100 meter from the heart, the acceleration due to gravity will be far, far higher than when it is 100 kilometer, from the surface of the earth, because that will make this to be higher and the acceleration due to gravity will reduce. So, meaning that for you to calculate the gravitational potential, you need to use another formula, because this formula, which is mgh, assume that the force is uniform, whereas in gravitational field, the force is not uniform throughout the field. The, the farther away the body is from the earth, so also the lower the gravitational force. So therefore, what is the formula that you will have to use when the distance between the body and the earth is significant? From this formula, I said the force of attraction between the two of them, the body and the heart, is this. And I earlier said that the work done, which is the energy expended, the work done is equals to force times distance. Okay? And recall that this r squared too is distance. So if we substitute this in this formula, what are we going to get? Let's say this is this d, let's turn it to r because both of them are distance. So if we substitute this into this formula, we are going to get work done is equals to the force, which will now be this GME times M divided by R squared times R, which is the force times the distance. Okay, so this R will cancel this. Therefore, the work done will be equals to GME times the mass of the body all over the distance between them. And from the principle of conservation of energy, work done is equals to the energy expended. Okay, therefore, this will be the gravitational potential energy. Okay, and take note that gravitational potential energy is always negative. Why is it always negative? The reason is simple. The reason why it is negative is because as you move the body away from the heart towards the infinity, this infinity, the heart does not have the force of attraction between the heart and the body reduces. So it will get to a time that the body, the heart, it will get to a time where the gravitational potential energy will be zero. Okay, so if the gravitational potential energy of the body is increasing, okay, and to reach zero, it means where it is coming from is negative. Therefore, the gravitational potential energy is equals to minus g me times the mass of the body divided by the distance between them. So always remember this negative. You can be asked this in your exam. If you enjoy this video, kindly like, subscribe to my channel and share for others to benefit. When you click the subscribe button, a bell icon will pop up. Click it. It's a notification bell for you to be aware when I upload these new videos. Thank you for watching and take care. Till I see you in my next video. Thanks for watching and bye bye.